So welcome back to the .NET Conf bunker here at Channel 9. It's
Late.
it's about 4 in the morning here, Pacific Standard Time. But we are having an amazing time with .NET Conf. Thanks so much, everybody that's tuning in wherever you are around the world. We're broadcasting now so that it's a lot more convenient for you. You've got folks from your regions, your areas presenting to you. We've got folks on 6 of the 7 continents. It's amazing.
It's amazing.
It is awesome.
We couldn't get Antarctica.
Couldn't get Antarctica.
I try to have friends there that hang out with penguins, but they were a little busy with the penguins.
Look at that. It's almost lunchtime in the UK.
It's good stuff.
Oh, man.
And I think where's our next talk coming from?
I think our next talk is coming from London. We're going to be going to, you know what, let's see if we can start bringing them in now. We're going to be going to Mete in London.
I love the flyover.
We got the fly-in, absolutely.
Brilliant. Did you pre-program each one of those, or did we just go to
All
that
of them.
location?
Absolutely.
You're like the script kiddie, man.
There we go. Hey, good morning. Happy lunchtime, Mete.
Hello, can you hear me?
Yes, absolutely.
Yes.
Good. Thanks for the introduction. Shall I start, or you guys want
Absolutely.
to do
It's all yours. You have the conference.
Great.
The whole world's
Hello,
watching.
everyone. Great. That's why I love online conferences, because the whole world is your audience, basically. So I don't know where people are, but I'm based in London. It's lunchtime in London, but I'm sacrificing my lunch so I can talk to you guys, because I did this conference last year. Last year I talked about ASP.NET Core containers on Kubernetes, and it was a lot of fun. So I'm very happy to be here again today. My name is Meta Tamel. I am a developer advocate at Google. This is my Twitter. I already have the slides, a version of the slides on my Twitter. So if you want to get the slides, just follow me. The application that I'm going to show is already on GitHub. I don't know if you can see this at the bottom of my slides. And I'm going to, at the end of my talk, will also provide the link to that as well. So if you want to run the app yourself, look at the code, all that kind of stuff, you can get it from on GitHub. To save some bandwidth, I'm going to turn off my video, and then we'll start the presentation. So let me do that. I think that worked. And let me move this around. Okay. All right. So the talk is about connecting. This time, I'm still talking about .NET containers, but this time connecting Google Home device to a .NET container. And you might be wondering, like, where is this coming from? How did you get this idea? Oh, okay. Sorry about that. So let me turn that on. Can you see it now? Is it? You see my camera, but I had to do screen sharing, I guess. Let's see. I haven't used Skype for a while. Yeah. Hold on. Where do I get the screen sharing in Skype? Share screen, yeah. Yeah, I got it. Now I can turn off the video. Now everything should be good. Right? Okay. Cool. Now you should be able to see my screen. So anyway, so what I was saying is that so me and my coworker Chris Bacon, he's a C# developer in Google Cloud Libraries team. We wanted to do a talk at the beginning of the year, and we were thinking something cool to show. And then we said, okay, well, Google Home is kind of hot nowadays, and why don't we just look into Google Home, see if we can program it, So that's how the idea started. Initially, we thought it would be really difficult because, when you talk about a device like a Google Home, you need to talk to it. It needs to understand what you're saying. Then, once you get the input from the user, you need to parse it, try to understand what the user is saying, get the entities out of the words. And then you need to somehow respond to that, right? So just thinking about this, our initial assumption was that this would be quite difficult to do. But we got the Hello World application working really quickly. And then we were like, okay, what else we can do with this? And then the idea came along. We have the device, people talking to it. We have the cloud with all the big data and all machine learning, all the APIs and everything that the cloud provides. So what does it take to connect it to the cloud? Again, initially our idea was that it would take a long time, but it was really quick. We were able to relay a user's request to the cloud quite fast. And then from then on, it was pure fun. We basically said, okay, let's use some machine learning to do something interesting, and then let's use some big data processing to elevate the Google Home application. And in the end, we have this application. So this talk is about that. We'll go through it and see how it works. But before I start my presentation, I want to first make sure that my application is working. I don't have a Google Home device here right now, but I'm going to use a simulator. So what I'm going to do is let me lower this. So here, this is a Google Assistant simulator. So I'm going to be using this. And I also have a front end for my application that I'll show you later. So first, let's start with this. One thing to mention, when you write an application for Google Home, you need to choose a phrase that triggers your application. Because normally when you talk to a Google Home device, if you ask something like, how is the weather? That will be handled by Google, right? Because Google has the weather data, so that will be handled by Google. But if at some point you want the control to go to your application, then there has to be some key phrases that triggers your application. So for example, if you write a stock application, you would say, talk to my stock application. Or if it's a shopping application, you would say, talk to my shopping application, something like that. But since this is a test application, the way you would test the test applications is that you would just say, talk to my test application. That's how you start. So that's why every time, not every time, but most of the times when I show this, I have to say, talk to my test application so that I can move the control to my test. So let's do that. And the cool thing about the simulator is that you can type it or you can talk to it. So I usually try to talk, but sometimes if it doesn't understand me, then I will type it. So we'll see what happens. So let's just start with talk to my test application. Or you can also click on this. So it's telling me there's a suggested input. So let's just click on it to make it easy.
Okay, let's get the test version of my test app.
Hello from Google Home meets .NET Containers app.
Yeah, so as you can see, this hello from Google Home meets .NET Containers app, it's coming from my application. So at this point, the control is in my application. So let's just ask something to our application. Can you say hi to everyone?
Hello .NET Conference people all over the world. Great to be here today.
Great, so it seems that my application is working. So we'll get back to this. I just want to double check that everything is working. So let's go back to the presentation. So before I get into details, I just want to give you an overview of how this application looks like and get some terminology straight. So first of all, I am talking, like, the idea of our application was that we would talk to Google Home application, and then that would be caught by Google Assistant. Actually, all these applications, I call them Google Home applications, but they're actually Google Assistant applications. Google Assistant is the thing that captures the voice on many devices. For example, if you have an Android phone, then you would have Google Assistant there. If you have Google Home, you would have Google Assistant there. The simulator has it. So any device that has Google Assistant has this application enabled, basically. So what happens is that the user talks to the device that they have, whatever it is, then it goes to Google Assistant. And at that point, Google Assistant decides, is this something I'm going to handle, or is this something I need to pass in to a custom application? If it's a Google kind of information, like how is the weather, or what's the stock price of Google or something like that, then that will be handled directly by Google. But then if you trigger your application, then the control will pass to your application. In this case, I'm using something called Dialogflow, and we'll talk about Dialogflow. But basically, from Google Assistant, if you want to extend Google Assistant, you would use something called Actions on Google. Actions on Google is the framework to extend Google Assistant. And then there's something else called Dialogflow, which is a framework even for, that wraps Actions on Google. And I'm going to explain the differences of what Actions on Google is and what Dialogflow is and why we use Dialogflow. But eventually, the control goes to Dialogflow. And Dialogflow, in a similar way, it makes the same kind of decision. It first tries to see if it can handle the user's response within Dialogflow. And if it can, it will just handle it and return a response back. If not, it can also call an endpoint. And that endpoint, it can live anywhere, but it has to be an HTTPS endpoint. That's the only requirement. So a request comes in, Dialogflow says, okay, can I handle this? If it can, it will handle it. Otherwise, it will pass it to this HTTPS endpoint that you defined. And then from then on, the code handles the response, the user's request. In our case, we are running an ASP.NET Core application in Google Cloud. And this application, it's basically an ASP.NET Core container. We deployed it on App Engine, but you can also deploy it on something like Kubernetes engine as well. So you can run on Kubernetes as well. As long as it's HTTPS, it doesn't really matter where it's running. And I'm going to talk about the differences between the two and why we deploy to App Engine. And then from then on, once we made that connection, we basically integrated with Google Search to search for some images that I'm going to show. Then we integrated with Vision API to get some intelligence out of the images using machine learning. Then we integrated with BigQuery to analyze some big data and get some intelligence back to the user. And finally, no application is complete without logging, tracing, monitoring, and debugging, right? So for that, we integrated with Stackdriver, and that gives us all the things that we need to maintain the application. So in a nutshell, this is the application. And I just want to take you through this journey of how we built this application and what kind of stuff you can do with it. All right? So let's first talk about Dialogflow. What is Dialogflow? Dialogflow, it's an end-to-end development platform for building conversational applications. So if you want to build an app for Google Home, or if you want to build an app, a chatbot or something like that, where people can actually talk to it, or they can also type to it, like they can also text to it, then you can use Dialogflow. The great thing about Dialogflow is that it has integration with many technologies. So it has integration with Google Assistant that I'm going to show. But you can also integrate it with Skype, or you can integrate it with Slack, or you can integrate it with Twitter. So there's lots of integration points. So you can use Dialogflow as like the one thing that you can use to integrate with many places. In this demo, I'm only integrating with Assistant, but I think it's useful to know that you can integrate it with multiple sources if you want to. It works on phones, it works on home devices. It pretty much tries to work on everywhere it can. And it also tries to work all around the world. So it's not a US only service, or it's not a Europe only service. It works across the globe, and it supports multiple languages as well. It doesn't support every single language, but there's a list of languages. I think it's like 10 languages right now, and the list is growing as well. And as I mentioned, Dialogflow, it's a channel for Google Assistant. So you can use actions on Google SDK to program Google Assistant, and that works. But actions on Google SDK is kind of limited. It basically, like when you use it, it will get you what user said, but then you need to make sense of what the user said yourself, and then you need to program that yourself. So it's not so easy. Whereas Dialogflow, it provides natural language processing, so you can actually extract entities out of these text, these expressions that the user said. But it also provides a really nice UI where you can define the conversation in a UI basically, instead of doing it in all in code. And I'm going to show this shortly. So that's why we try to use Dialogflow, because it makes it really easy to kind of integrate what user said and extract things and display them. So I mentioned the natural language processing in Dialogflow. So for example, if you say something like book a flight from Los Angeles to Hawaii for less than $300, what Dialogflow does is that it first of all, it detects this, and then it tries to extract entities from this expression. So in this expression, Los Angeles is a city, so it will pick out the fact that this is a city, Hawaii is a state, and then $300, its amount, and it's like its currency basically. So it will pick those out for you, and it will give them to your application to process. And that's very useful, because you can literally like mark what you want to be extracted, and it will do that job for you, so you don't have to do that yourself. And it's quite smart. You don't actually have to give the full list of things that it should extract. You just give some examples, and it learns from it. And I'm going to show you this shortly. All right, so that's Dialogflow. What I want to do is I want to show you the Dialogflow console first. So there's a console for Dialogflow. So this is where you would start your project. The first thing that you need to do is you need to create an agent. You can think of agent as kind of like the project or your application. Here I have two agents. One is a Hello World agent, and the other one is Google Home Meets.NET agent. In the agent, you have like the the description of the agent, the time zone, the language, stuff like that. And there's also different APIs that you can use, but I'm using the latest V2 API. So once you have the basic agent, you usually don't need to change much here. What you can do though is that you can export and import agents. So once you have your agent set up the way you want, you can actually export it in a zip file, and someone can import it and use it. And actually, if you get the code for this application, I have the agent exported already for you. So you can just simply open Dialogflow and import my agent, and you have all the stuff that I'm showing to you from that zip file. So once you have the agent, then you need to tell the agent what kind of things that it should listen for, right? And those are called intents. So if you look at under intents, there are a couple of things to note. First is there's something called default welcome intent. This is the intent that gets triggered when you say, talk to my test app, or talk to my stock application, or something like that. When you say that, then it will trigger this default welcome intent. If you look at here, so there's this is the welcome intent, and the response is, we define the response here. So here I'm saying hello from Google Home Meets.NET Containers app. So this is the response that I defined. So that's how we can trigger this. This is an intent that's solely handled in Dialogflow. So a request comes in, like I say, talk to my test app, it goes to Dialogflow, and Dialogflow can handle directly right here using this text. The other one is default fallback intent. So if you say something to Dialogflow and the Dialogflow doesn't understand it, then it will fall back here. So it's kind of like the default way of handling requests. And here, as you can see, there's no request or there's no training phrase or anything like that. There's only responses. So when you say something that Dialogflow doesn't understand, then it will pick one of these text responses and it will just say something like, what was that? I didn't get that. I missed that, stuff like that. But you can choose whatever you want in here. And the last thing I want to show here is remember I said, say hi to everyone. For that, I use this greeting.conference intent. So if you look at this intent, the first thing that you'll realize is that I have some training phrases. So the training phrases are greet everyone, say hi to everyone, say hi. So any of these phrases will trigger this, but not just these phrases, anything that's similar to this. So if I say hello to everyone, it will still trigger this. That's what I like about Dialogflow, is that you just give it examples. You don't list everything. But if you say something like this, then it will get here, and the text response, again, will be handled by Dialogflow. So that's what we have. Let me go back to my presentation now. So we got the initial Dialogflow application working quite quickly. The next thing that we wanted to do is we wanted to connect it to the cloud. And then, nowadays, like, containers is the default way of, for many people, is the default way of like packaging and running applications. So I just want to talk about containers on Google Cloud briefly and the choices that we made, and then I'm going to show you more stuff. So basically what we did is that we created an ASP.NET Core application, and we deployed it to App Engine, but it can also work on Google Kubernetes Engine. And I just want to briefly cover what the differences are. So when it comes to deploying your code on Google Cloud, this is kind of like the spectrum that you have. On the spectrum, on one side, you have Compute Engine, which is basically virtual machines on Google Cloud. You can have Windows virtual machines, Windows Server virtual machines with different versions. You can have a bunch of different Linux kind of virtual machines. And you can also have container optimized virtual machines. So if you want to run containers on a VM for whatever reason, you can do that as well. On the other end of the spectrum, we have Cloud Functions. These are basically serverless Node.js or Python functions that you can deploy, and you don't care where they're running. They're just automatically maintained and run by Google for you. And then in the middle, we have App Engine and Kubernetes. So these are kind of like the two choices that you have when it comes to running containers. The easiest way to run containers is App Engine. So in App Engine, you basically just define your application, define a Docker file, and just say gcloud app deploy, and it will deploy it to App Engine. Under the covers, App Engine will run your containers on 2 VMs, but it will automatically scale up to 20 VMs. But all that is abstracted away from you, so you don't have to worry about that. And then there's Kubernetes Engine for those people who want to run containers on Kubernetes. And the choice is really up to you. Like, you can do both. If you want more control, you probably want to go with Kubernetes Engine. But if you want just ease of use and you just want to say, okay, this is my code, just run it, then you will probably go with App Engine. So App Engine, what does it give to you? It basically, you just say, this is my container, run it, and it will just run your container, and it will scale it for you automatically. It gives you dashboards. It gives you versions. So every time you deploy your application, you have multiple versions. Once you have the versions, you can do traffic splitting, and it has auto-scaling. So it gives you the default things that you want with just a single command. You just say gcloud app deploy, and by that, you get all these features. And if you want more control, as I mentioned, you can use Kubernetes. And I think in the previous talk, we talked about Kubernetes, so I'm not going to cover it too much, but it's basically one of the most popular open source container management platforms. And there's something called Google Kubernetes Engine, which you can think of as Kubernetes as a service. It's Kubernetes maintained by Google for you. So with a single command, you can get a Kubernetes cluster with master and worker nodes, and you can deploy your containers using kubectl, just like any other Kubernetes cluster. So these are the options that you have. So let's ask our application where it is running. So I will go back to my simulator. And this is the front end of my application. So we have a simple front end, ASP.NET front end. So what I'm going to do here is I'm going to ask my application where it's running. Where are you running?
Running on Google App Engine. Project ID is home meets.NET containers.
Yeah, as you can see now, it's telling us that it's running on App Engine. So we kind of made the connection from our application, from Google Home, Dialogflow to the cloud now. And I want to show you briefly what kind of things you need to make this connection. And then we'll move on with more interesting things with machine learning and big data. So first, let's go to Dialogflow console again. So one thing that you realize is that in Dialogflow console, in one of the intents, I have something called platform.describe. So this is the intent that handles when I say, what environment are you running in, or where are you running, things like that. So when you say that, it will trigger this intent. And then, as you can see, there's no response here. So there's no text response. But what's happening is that there's this checkbox here that says enable webhook call for this intent. So that says to Dialogflow, don't try to handle this yourself. Just call this webhook that I want you to call, right? And where is this webhook? It's defined under here, fulfillment. So in fulfillment, there's a URL that you have to enter. It has to be HTTPS. So this is basically my App Engine endpoint that I already deployed that's going to handle the webhook calls from Dialogflow. By the way, I should also mention there's an inline editor here where you can also define a function in Node.js in here, and you can deploy it to Google Cloud using something called Firebase. So you can basically define the function in here and just deploy it right from here. And it's the easiest way to basically define webhooks right from here. But we chose not to do this because we're going to have lots of intents with lots of logic in them. And trying to do all of that in here, it doesn't make sense. So that's why we also we wanted to do it separately ourselves. Also, to be honest, I mean, who wants to write Node.js when you have C#, right? I mean, I know some people are going to yell at me for that, but I mean, when you have C#, you want to write in C#, at least for me. So that's why we didn't bother with this one. All right. So that's the so that's how you define the webhook. And now at this point, it will get into our code. So let me just show you some of our code. So this code is on GitHub, by the way. But let me just show you the flow. So what happens? So we have this is an ASP.NET Core web app. And we have a conversation controller. So this conversation controller is the thing that handles the conversation calls from Dialogflow, okay? So it will basically get here, this conversation route, and then we'll get the HTTPS request right here. And this will call Dialogflow app handle request. So let's look at Dialogflow app. So under Dialogflow folder, there's a Dialogflow app. And if you look at the handle request, it gets the HTTPS request, and what it tries to do is it tries to extract a webhook request from the body of the HTTP request. What is this webhook request? It's basically a Dialogflow thing. So if you look at the top of our file, there's a Google Cloud Dialogflow v2 NuGet package that we're using. So once I have that package, I can use that and I can extract the webhook request. So basically the contents of the Dialogflow request from the body of the HTTP request. So once I have that, I have things like the session. So every conversation has a session in Dialogflow, and I can see the intents and the intent's name and things like that. So I have basically the context of the call from this webhook request. So what's happening here is that I have the session ID from Dialogflow, and what I need to do is I need to decide whether this is a new conversation, they just started talking to me right now, or whether it's an existing conversation. So this method, get or create conversation, figures out whether to create a conversation or to get an existing conversation. And once we have the conversation, either way, we call the handle async method. So we are passing the request down the chain. So if you look at the conversation, it gets the webhook request, and it takes the intent name from the request. And now we want to match the intent that we define in Dialogflow to a handler on the server, right? So this find handler method does that. It looks at the intent name and it finds a handler for it. How it does it, I'm not going to go through the code. The code is here if you want to take a look at it. But in a nutshell, if you look at the intents, so all the intents are under the intents folder. And if you look at the platform describe handler, you will realize that at the top, there is an intent tag. And this intent tag has the same intent name as the one in Dialogflow. So by having this intent tag with this value, we are basically matching the intent of Dialogflow to a handler on the server. That's how it happens. So we'll get here and we'll get the request here. And what we are doing here is that this platform.instance async, it's a Google Cloud API call. So Google Cloud is basically figuring out where we are running. And at this point, it will figure out the fact that we are running on App Engine. And then once we have the detailed description of where we're running, we do two things. We have Dialogflow show call. This will display on the web page whatever we pass. So we pass in the text we get and display it on the page. And we also return a webhook response, and we say fulfillment text. So this fulfillment text is basically telling Dialogflow, just say whatever I told you to say. So this spoken description here is what I'm telling Dialogflow to say. Okay, so that's the whole chain. Like Dialogflow goes to an HTTPS endpoint. From HTTPS endpoint, we go through the conversation. From conversation, we go to the intent handler, and from intent handler, we handle however we want, and then we just return a webhook response to Dialogflow, and that's it. Dialogflow will just say whatever we want to say. All right. Okay, so now we got, let me go back to my presentation one sec. Now at this stage, we have our Dialogflow connected to Google Cloud running on App Engine, so things can get more interesting, and this is the part of the talk that I have the most fun with. So what we're going to do is, at this stage, we said, okay, let's just see what we can use on Google Cloud to make this more interesting. And the first thing that we looked at is the machine learning APIs. So on Google Cloud and in other clouds as well, there is this APIs for consuming machine learning. By consuming machine learning, I mean, usually when you want to do machine learning, you need to have data. You need to be able to determine what you want to do with that data. Then you need to be able to train that data using machine learning. Then once you have a trained model, then you need to expose that model using an API. And once you have that API, then you can consume that intelligence that you got from machine learning, right? That's a lot of work. But then you can also rely on what's called machine learning APIs. These are APIs that expose a model that's already been trained for you. So for example, there's something called Cloud Speech to Text. What it does is that it takes the voice and it turns that into text using machine learning. It uses a model that Google already built to do that. Same thing for text to speech. So you can convert text to a human-sounding speech. And there's video intelligence API that you can extract intelligence from videos. Natural language is also really good. You can pass in some text in English, and it can detect whether the text is, a positive text or a negative text, or whether it's neutral. The things like that about the text. And my favorite is the Vision API. So in Vision API, you can pass in an image, and it will try to extract information about that image. Just to show you an example, so there's a demo. You can actually go to this demo yourself as well, called Vision Explorer. And what we can do in Vision Explorer is that we can pass in some images, and we can see what we get back. So for example, we pass in an image of a cat, And what you get back is basically something like this. It's just a JSON with some text, with some descriptions and scores. But if you look at it in detail in graphical way, we can see that we get some labels. So we pass this image to Vision API, and what we got is some labels. And Vision API is telling us that it's a cat, 99% or 99% sure. It's an animal, 96%, and it also knows that it's a British short-haired cat, 93%. So it gives you quite accurate information about the image. It gives you the colors in the image, the dominant colors in the image, and it also tells you whether this image is an adult image or a medical image or violent image, stuff like that. If you pass in an image with text, then it can extract text from the image as well. So for example, in this one, we have this traffic sign. So Vision API is telling us that this is traffic sign 90%, but it also picked up the text, and it tells you also where in the image the text is, right? So it can give you that as well. And the last thing I want to show is that if you pass in people to Vision API, it can detect people's expressions. For example, this one, it figured out that it's a social group, 98%, and maybe folk dance, 56%, which is pretty good. But for me, the interesting part is that if you turn this on, then it can detect people's faces, but it can also detect people's expressions. So person 1, which is the person here, Vision API is telling us that the person is very neutral, so there's not much expression, which seems to be true. And then person 2, which is this person, is joyful because she's smiling. So you can get this kind of information from Vision API. So what we wanted to do is we wanted to basically use Vision API, and what we did is, well, instead of me talking about it, let me just show you what we did, and then I can explain the details afterwards. So let's go back to my simulator, and I will say, let's try. Okay, move this around. I want to use Vision API.
Okay, you can ask Vision API to search for images first. What do you want to search for?
Search for images of London.
Found some pictures of London. Now, select a picture.
Select second picture.
Picture 2 selected. You can describe, show landmarks, or ask whether the image is safe.
So what happened right now is that we use Google custom search to search for images of London, and we got some images. We pick one, and now I'm going to use Vision API to describe the image, get the labels out of it, and do landmark detection to see if there's a landmark, and also do a safety check whether this image is safe or not. So let's see if it works. Can you describe the image?
This picture is labeled city, cityscape, landmark, tourist attraction, skyline, urban area, Ferris wheel, metropolis, bridge, and metropolitan area.
So that seems pretty accurate. And then let's see if there are any landmarks here. Are there any landmarks in this picture?
This picture contains London Eye.
Okay, one interesting thing is that it picked up, it thought I said, are there any rabbits in this picture? But somehow it went to landmark detection. I don't know how that happened, but it works. And then let's do the safety check now. Is the picture safe?
Let's see. This picture is fine.
Yeah, so it's telling us that the picture is fine. So yeah, we just use machine learning in our application. And let me just show you quickly how this looks in the code. Well, before the code, let's look at the Dialogflow console first. So we can close this. So if you look at the Dialogflow console, start with intents. So we have a number of vision-related intents. The first one is vision.intro. So this one, when you say, I want to use Vision API, it will trigger this. And all it does is it will set what's called an input context and an output context. So input context in an intent means that this intent will only be triggered when you have this input context. In this case, this intent will be triggered no matter what, right? But the output context means that when this intent gets called, at the end of it, it will set this vision context. So when you say I want to use a Vision API, it basically sets the context to Vision. All right. So that's all it does. And this is important because if you look at the other Vision intents, the first thing that we do is Vision search. So the Vision search has Vision context as input, right? So this will be only triggered if we are in Vision context. So that's how you can control what gets triggered when, right? And then it also has some output context like search and Vision. But one cool thing here is that the training phrases here in Vision.search is that I say, let's see some dogs pictures. As you can see, like I didn't say dogs in my demo, I said London. But what's happening is that we are marking this, we are providing these expressions, and we are marking dog as special entity that we want Dialogflow to pick for us, right? And this entity, we call it search term, right? So, and what happens is that the Dialogflow will say, when you say, show me images of London, it will pick London and it will insert it as search term in the request, and we can pick that search term and use it later, right? So this is the entity detection of Dialogflow that we're getting for free, which is nice. And then let me show you the other intents as well, and then we'll look at the code. So that's image search. And once we search the image, we select the image. That's not that interesting. It's basically selecting one of the images. And then Vision.describe is the one that actually makes the call to Vision API. So in here, as you can see, the context is Vision.select. So this only gets called when we have an image that we selected. Otherwise, this intent doesn't get called, which makes sense. And then these are the phrases that triggers this intent, such as describe this image. And then response is a webhook call, right? There's no response. Our code will handle this. And it's true for the other ones as well. If you look at the Vision.landmarks, this will also be triggered, and it will be calling our code as well. So now we can actually look at our code. Let's go to Visual Studio Code. In here, under intents, there's a Vision folder, and then let's look at the search first. So if you look at the search, eventually the webhook request will end up in this method. And what we are doing is that we are picking up the search term. So this is a search term that was picked up by Dialogflow and passed to us, right? So we pick that up, and then what we do is we create a search client. So this is a Google custom search API that we are using. We are searching for images. We get some images back, and then we display that image in our front end, and then we send a response to Dialogflow. And so this is basically what we want Dialogflow to say, and it will say, found some pictures of London, now select the picture, right? So that's how you search it. It's quite easy. Then Vision Select will basically, we don't have to look at the details, but it will basically, when you say select the first picture, that will be passed in as index from Dialogflow, and then we'll use that index to select the picture. And then the machine learning happens in Describe. So in Describe, one thing that you'll first realize is that we are using google.cloud.vision.v1. So that's the NuGet package to talk to Vision API. And what we are doing is that we get the request again. We create a Vision client. So this is the actual class we use to call the Vision API. And we just make a single call. In this case, detect labels async. So this says, given this image, which you basically just point to the image URL, we just say call label detection on this image, and this gives us some labels. And then we just basically take those labels and we just say this picture is labeled, blah, 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 blah. We just talk about that, right? So that's it. It's just one API call to Vision API. Same thing with landmark detection. If you look at landmark detection, again, Vision client, detect landmarks, almost the same kind of code. And safety detection is also the same. So if you look at safety detection, have a client and detect safe search async, that's it. So it's cool that we can do machine learning with a single call, but that's what the machine learning APIs are for. And yeah, that's what we used. So that was one. The second that we wanted to use was BigQuery. Let me go back to my presentation briefly. So BigQuery is Google's, so that's Vision API. Yeah, so BigQuery is Google's massively parallel processing engine, basically. So the idea of BigQuery is that you ingest your data, and in this case, I mean like terabytes of data. BigQuery works better and better with more and more data. So if you have lots of data, you can ingest it, and BigQuery stores it. It has a lot of storage behind it, and it has a lot of compute behind it. And the idea is that you run SQL queries against this big data, and it runs really fast because BigQuery is really optimized to take the query, split the query into smaller queries, and just run it as fast as possible, right? So it's fully managed, so you don't have to worry about clusters, machines, anything like that. And the thing about BigQuery is that it comes with public data sets. So if you go to this page on Google Cloud, BigQuery public data, there's all this public data that's available in BigQuery that you can use to try it out, or even use in your application if you want, on things like GitHub data, for example. You can search for all GitHub commits and everything that's on GitHub. It's ingested in BigQuery. There's Hacker News, so everything on Hacker News is ingested. So we wanted to use some of these. And actually, before I show the application, I want to point out to one of my coworkers, Felipe Hoffa. He's also a developer advocate in my group. He actually analyzed GitHub data using BigQuery, and he figured out which companies are the top contributors to open source using GitHub data. And he has a blog post about it that he explains. What you can do is basically I won't go into details, but what you can go to Google Cloud, and you can go to BigQuery. And let's just go here, BigQuery, and then I just copied and pasted his SQL statement. So I have one here, GitHub top contributors. Let's just move this around. So if you look at this is just the SQL statement. It's quite complicated, but he explains what he does in the blog post. But if you run the query, now this is gonna look at the GitHub data, and it will basically look at all the commits. It will look at the emails attached to the commits, and it will try to figure out if the person has a company email like at google.com or at microsoft.com, and it will count it, and it will display like what company has the most contribution. This ran, and it looks like Microsoft has the top contribution with Google close second, and Red Hat and IBM and stuff like that, which is pretty cool. But what's even more cool is that this query completed in 20 seconds. It processed like almost 900 gigs of data, right? And I did this with just one click. And to me, that's really impressive. So we wanted to use this in our application. Again, instead of me talking about it, let me just show you what we did. So first thing that I want to do is I want to search for news.
Okay, you can ask BigQuery about top hacker news or global temperatures on a certain day.
So yeah, in BigQuery, there's like two public data sets that we were interested in. One was Hacker News. We wanted to search everything that happened on Hacker News. And there's another data set was global temperatures. So there's a data set where, we keep, the data set keeps track of all the global temperatures in all countries since like 1910 or something like that. So let's try Hacker News first. What was top hacker news on May 1st, 2018? Now it's running the SQL statement seen here. And now the BigQuery call is going.
Scan 697 megabytes in 4.6 seconds. The top title on Hacker News was titled, Amazon Threatens to Suspend Signal's Oz Account Over Censorship Circumvention.
Interesting. Yeah, so you can see like we are running SQL, and we got some stats about the BigQuery run, and then we are displaying the top 10 hacker news on May 1st, 2018, and that was pretty quick. And the second one is the global temperature, so let's ask about that as well. What was the hottest temperature in USA in 2016? Now it's running another SQL statement against the global temperature.
Scanned 5,271 megabytes in 2.9 seconds.
Yeah.
The hottest temperature in United States of America in the year 2016 was 48.7 degrees Celsius at the Stovepipe Wells 1SW monitoring station.
Yeah, I don't know where that is, but that looks like a really high number. Like 48 degrees is probably like 120, 130 Fahrenheit, I guess. I don't know, but that's a lot. And you can ask like coldest temperature as well, and in pretty much any country. And the way we did this, again, just to show you briefly, is that if we go to Dialogflow console, intents, so BigQuery intro sets the BigQuery context, just like before. And then once we have the context, there's, let's look at Hacker News. So the Hacker News gets called when we are in BigQuery context. And the training phrase is what was on Hacker News yesterday, what was the top Hacker News yesterday. We are just picking up the date. And again, like here, I'm giving one example with a date, but you can also say yesterday. And as long as you mark these and you tell Dialogflow, just pick this thing as date, it will figure out what yesterday is and it will give you a proper date. That's the cool thing about it. So we basically pick up the date and we pass it to BigQuery code that I'm going to show you. And the same thing with the temperatures. In temperatures, we have more things to look for. So we are looking for the hottest temperature in France in 2015. So we are picking up hottest or coldest or highest or lowest. And we are picking up country, so France, and we are picking up the year, right? So the entities are more complicated here. But again, Dialogflow is doing the work for us. And by the way, if you say in 2015, what was the highest temperature? And if you don't say the country, then Dialogflow will prompt you and say which country, which is pretty cool as well. So because these are marked as required, right? So since they are marked as required, Dialogflow will make sure that the user provides that. So I don't have to worry about that myself. All right. And just to look at the code again, we go to BigQuery. Let's look at Hacker News first. The first thing that we're going to do is we're going to use the BigQuery NuGet package that we have. And then it will get into handle async. We will, from the request, the webhook request that Dialogflow gives us, we pick up the date. That's the only thing that we are interested in Hacker News. Then we create a BigQuery client that we'll use to talk to BigQuery. We specify the table, the public data sets that we want to get the information from. We define the SQL statement, and we define the parameter, in this case, the date. So that's the only thing that we pass it to SQL statement. And we show the query in our web page, and then we start the clock so that we can time how long it takes. And then we execute the query, and then we get the results. And in the end, we show the query to people in the browser, and we also do a response. So the fulfillment text will say, the fulfillment text, so Dialogflow will basically just say the stats about the query. So scan this many megabytes in this amount of time, stuff like that. And the same thing with the global temperatures. The only thing that's different in global temperatures really is that there's more things to extract from the requests. So that logic is here. So I'm looking at all the things that Dialogflow should provide to me and doing some kind of error checking. So if there's something that the Dialogflow is not giving to me, then I'm going to say something. And the rest is pretty much the same. I won't show you the rest of the code because it's pretty much the same. Yeah, so that's how we got BigQuery integrated. And the last thing that I want to show you, I want to wrap up in 5 minutes, but I want to make sure that I show this to you because it's kind of important. You know, this is all cool. Like we can integrate with cloud, we have machine learning, we have big data, but all of this means nothing if you cannot maintain your application. So for that, we thought that it was really important to use something like Stackdriver to maintain our application. And what is Stackdriver? It's basically Google Cloud's monitoring, logging, debugging, error reporting, tracing tool. So logging is like a central place where all the logs can go. Error reporting is anything that you throw from your application that's not caught. It will be reported here, and you get stats about the errors. Tracing is HTTP tracing. So all the calls into your application will be traced, and you can see the stats about them as well. And finally, the thing that I want to show you is debugging. So you can actually point to your code on GitHub and get that loaded in your browser, put a breakpoint, and get a snapshot on a live application running in the cloud. Okay, so I just want to, in 5 minutes, just show you quickly what we have here. But before that, to enable Stackdriver, all I have to do is in my application, if I go to not startup to the program.cs, yeah, when I create my application, I just say use Google Diagnostic, pass in my project ID, service name, and the version of my application, and that's it. This will enable Stackdriver for me, right? So with this, I have my Stackdriver enabled. And also in your Docker file, you need to start If you want to use debugger, you need to start in a special way, but it's basically just you wrap .NET call with start.-debugger, and that's it. And once you do that, what you get is that I come here, I go to Stackdriver in Google Cloud Console. So let's look at logging first. So logging, not exciting, but it's useful. It's a central place where you can see, like, this is my App Engine application, version 6 on my application, and I can see all my logs. I can do search and stuff like that here, which is really useful. The other thing is the tracing. So all the HTTP calls in my application, they're traced. So I have a long poll endpoint where my web page is calling once in a while, so I can see the long poll calls. I have the conversation endpoint where Dialogflow is calling, so I can click on conversation, and I can see the calls that are being made and when they are being made. And if I click on the actual call itself, I can also see what's being called underneath. So here I see that conversation calls Dialogflow app, Dialogflow calls conversation, and then that eventually ends up in BigQuery call that we just made. So all this stuff is there. And the other thing is the error reporting. So if you look at error reporting, my application, it has some timeout issues that I didn't fix on purpose, so I can show it to you. So as you can see, there's timeout exceptions that's been happening. I can see how often they happened, and if I can link to an issue, if there's an issue in it, and I can get someone to be called if I want to. So it's very useful as well. But the thing that I want to show before I finish my talk is debugging. So what you can do in debugging is that first you point to your source code. You can go here, add source code, and point to GitHub. That will load your code here. It won't load it in Google Cloud, so we won't see your code. It will only load it in the browser. Then you can see your code just like here, and you can put breakpoints. So for example, this vision search handler is the handler that gets called when we search for an image, right? So I can come here and I can just say, yeah, I want to look at the search term, for example. Maybe there's something wrong with the search term. So I can do a breakpoint here. And now what's happening is that Stackdriver is waiting for this to be hit. When it gets hit, it will take a snapshot of the call and all the variables, but it will continue running, so it won't stop anything. So if we go back, just to see that this is working, if we go back to our application, let's do this. And let's say I want to use Vision API.
Okay, you can ask Vision API to search for images first. What do you want to search for?
Search for images of London.
Found some pictures of London. Now, select a picture.
Now, if you go back here, as you can see, I mean, you couldn't really see, but what happened is that this actually captured. It was already captured, and I can already see that search term is London, right? But my application is running, it's in the production. I mean, to me, this is really valuable because anyone who has done any kind of production debugging knows how hard it is and how hard it is to instrument your code and application. So having this is very, very valuable for me. And I think that's all I wanted to say. Let me just double check. Yeah, that's Stackdriver, and yeah, that's all I have to say. If you want the slides, this is my Twitter. I already have the slides from 2 days ago. And if you want to have the code, this is a link to GitHub. There's a README there that explains how to set it up yourself. It's not that complicated, so you can play with it if you want. And yeah, I guess in the last 5-10 minutes, we can have some questions.
Good.
Are there any questions?
So I don't see any questions right now. There's definitely a lot of people out there in the chat room that are interested and have been tuning in and watching with us. Now, you have a real long link there. Can you do me a favor and send me the link to that repository back in an email a little bit later, and we'll make sure we attach that link to the video, the recording for this, so that folks are able to get it, because we want to make sure that people are able to get to that demo, because you showed some really cool stuff.
That was cool.
So I love how, right, I mean, we're really showing just how across everything .NET is, right? We worked with, you saw Google Home, you saw, GKE, you saw all this on a Mac.
All of it on Mac, which is what I'm using.
Exactly, yeah. I mean, 3 years ago, you couldn't think of this, and now I run everything on Mac, running on Linux, that's amazing.
Absolutely.
It's absolutely amazing. I had a question about that cloud, that awesome image cloud. What's that? Mind if I ask what that's rated? Is that all? I mean, that was in your browser, wasn't it? That was amazing looking.
Which cloud you mean?
The universe visualization.
Yeah.
Oh, the Vision API thing.
That was neat looking. I really, really like that. It kind of reminded me of a
Yeah,
graphic.
it's a demo. Maybe you can attach that to the show notes as well. Like it's a demo that's available. It's public, and it shows Vision API basically in a visual way.
Yeah, very, very cool stuff. Ultra Hall in the chat room is saying .NET is wicked cool in the correct hands. So compliments to you. Very good stuff.
Thank you. Yeah, and compliments to people who created .NET Core. To be honest.
That's good. I like that.
Right. That's the point of the open source. Everybody's collaborated, and we're all getting very cool stuff out of this. Well, I think that's all we're going to have time here. Thank you so much for joining us, Mete. This is great. We really appreciate it. Golf clap for you,
Thanks,
sir.
thanks very much for having me. It was again a lot of fun. Yeah.